All right, so we're continuing on. This would be part 2 of quadratic functions. Yesterday we talked about, well, we brought over our skills from translating, so shifting right, left, up, down. We talked about how to find the vertex, the axis, symmetry, domain, range. And then we said what happens if it's not in standard form, and we reviewed completing the square to put it into standard form. So that's one option. If it's not already in standard form, then we force it into standard form by completing the square. The second option is to keep it in quadratic form. So we would keep it so that it stays as ax squared plus bx plus c. And we find the vertex by doing negative b over 2a. That negative b over 2a gives the h coordinate of your vertex. And then to get the k coordinate of your vertex, you take the h and you plug it back in. Your axis symmetry is still x equals h. You can find your intercepts by either taking your original equation and factoring it, or using the quadratic formula. And then you would graph using that vertex and whatever intercepts you have. If those are not enough, if you don't have 3 points from your vertex and your intercepts, then we add in by plotting points. So in this method, you don't have to force it in to complete the square. You do the negative b over 2a, and again, plug it back in to get the k, and then find your intercepts. So example 6 just says, just find the vertex of f of x equals negative x squared minus 3x plus 7. So instead of forcing it in to complete the square, we could do that. Like we could also force this in to complete the square and then just take the hk out of it. Or we just do negative b over 2a, which is faster. So negative b over 2a. The a is what's in front of the x squared, which would be negative 1. The b is what's in front of the x, which would be negative 3. The c, which we don't need, but it would be it would be 7. So then I would get negative 3 over 2 times negative 1, which is 3 over negative 2. That's the x coordinate of my vertex. And then to find the y, we're going to plug it in. So negative 3 halves squared minus 3 times negative 3 halves plus 7. Negative 9 fourths plus 9 halves plus 7 would equal the y, which is going to be the k coordinate. From here, you have two choices. Either multiply everything by 4 to get rid of the fractions, but then you're going to have to bring it back at the end, or change all the right side so it has the same denominator. So 4 would be my least common denominator. I'd multiply by 2 and 2 here, and this by 4 and 4. So I get negative 9 fourths, positive 18 fourths, and positive 28 fourths. And then negative 9 and positive 18 would be positive 9. Positive 9 and 28 would be 37. And that would be k. So again, this time it's only asking for the vertex. I would obviously recommend this method. It is faster than completing the square. But let's say it had said put this into standard form, right? So let's say we had completed the square on this guy. Negative, because we didn't do one with a negative yet. If it looks like this, remember the first step is to group the first two terms. And then there's a negative on the front. We can't leave it. So we would take out a negative, and that changes the sign of both the x squared and the negative 3. What's the next step from here? How do I fill this space? Good. Take 3, divide it by 2, and then square it. So 3 halves squared would be 9 fourths. I'm going to add it inside the parentheses. And normally I'd subtract it from outside the parentheses. But if I took something out, which I did this time, that has to get multiplied by what I just wrote before I combine it with the number at the end. So this turns into a positive 9 fourths. And then 7 would be 28 fourths The negative stays on the front. Square root the x squared. Square root the 9/4. Take the sign from the middle, put it in parentheses and square it. And then add 28 9/4 plus 9/4, which is 37/4. And from there, my vertex, opposite of what follows x, so negative 3/2 and positive 37/4. So you would get the same answer, both methods. There are going to be times in which it says you have to put it into standard form, so I'd have to do it the second way. And then there's other times where it just asks you for the standard form, for the vertex, and in that case I would do the negative b over 2a method. But you can use either one. Questions on either of those? All right, now we get to max and min. So because we're talking about an absolute max and an absolute min, there will be only one of these. And we actually answer it by giving the y coordinate of it. If a is greater than 0, that means my parabola opens upward. Whatever the vertex is, this is my hk. The k value would be your minimum. If a is less than 0, it means it opens downward. My vertex would be at the top. That would be hk again. And the k would be the maximum. So when we're talking about absolute max and absolute min, it just wants the y coordinate of the vertex. All right, example 7 says, for the function f of x equals negative 3x squared plus 2x plus 5, identify the vertex, the x-intercepts, and use the graphing utility to verify. So you would want to think to yourself, can I do this both ways? Can I do standard form? Could I complete the square on this guy? Because it could ask you to do that, okay? And can I do negative b over 2a? Because sometimes, or a lot of times, that's faster if it's not in standard form. So I'm going to do the negative b over 2a because we practiced the complete the square yesterday. So first thing is h equals negative b over 2a. My a is negative 3. My b is 2. I get negative 2 over 2 times negative 3, which is positive 1/3. So that's the x coordinate of your vertex. How do I find the y coordinate? Plug it in. So negative 3 times 1/3 squared plus 2 times 1/3 plus 5. Square the 1/3, so negative 3 times 1/9 plus 2/3 plus 5. I can simplify this. 3 goes into 9 3 times, so negative 1/3 plus 2/3, and 5 over 1 becomes 15/3. Denominators are all the same, so add your numerators. Negative 1 plus 2 is 1, plus 15 is 16/3. And that's the y coordinate of my vertex. What's your axis of symmetry? I didn't ask for it, but you'll need to know it. What's the axis of symmetry? X equals 1/3, right? X equals good. The h coordinate of your vertex. And to find the x-intercepts, we're going to make y, which is f of x, 0. Again, my advice would be to check to see if it's factorable. If it's not factorable, you use quadratic. But if it's factorable, usually that's quicker. The test is multiply first times last. So negative 3 times 5 is negative 15. Are there factors of negative 15 that sum to positive 2? Yep, what are they? Good. Positive 5, negative 3. Replace your middle term with those two. And then factor by grouping. I could take out an x, or I could take out a negative x, doesn't matter. A positive x leaves that as negative 3x plus 5. And then it's already 3x, negative 3x plus 5. All I'd have to do is take out, technically I'm taking out a 1 there. If you had made the x negative, then it would have looked, so I could have gotten negative x, and then it would have been 3x minus 5, and then I would have had to grab a negative 1, 3x minus 5. Same answer will result in the end. So now I get negative 3x plus 5 and x plus 1. And then I split and solve. So negative 3x equals negative 5, and x equals 5/3, and x equals negative 1. So my x-intercepts would be negative 1, 0, and 5/3, 0. All right, then it says use a graphing utility to verify. So let's go to our graphing calculator and type in that equation. So negative 3, make sure you do the negative that's under the 3 because it's a leading negative. Negative 3x squared plus 2x plus 5 and graph. All right, so this is what my graph looks like, okay? So how could I verify what my vertex is? If I go to second trace, I don't have a button that says vertex, right? But on a parabola, the vertex is also what? It's either the max or the min. This one opens up, opens down, right? So this one, it would be the maximum. So if I go to max, and I am left of it already, and then I go right of it, and then I hit enter. And there I get my 0.33333, which is 1/3, and my 5.333, which is 5 1/3, which would be 16/3. So it confirms our answer for our vertex. And then if I want to find my intercepts, second trace, go to 0. I'm going to go left of the first one. I'm going to go right of the first one, hit enter. And that's my negative 1. Second trace, go to 0. Left of the first one, right of the first one. And 1.666, which would be 1 2/3, is the same thing as 5/3. So again, you're just using this to verify. If this was a homework question and it said use a graphing utility to verify, you don't have to include the picture in your homework. You're just using it to verify. If it said graph this and they answer a question based on it, then you have to include the picture in your homework, okay? Questions on that method? Okay. Now we flip-flop. So now I'm going to give you information about the graph, about a parabola, and you're going to give me the equation as its answer. So we're going to plug the vertex in as our HK. We're going to plug the point as our XY. We're going to solve for A, and then we're going to plug back just in the vertex and the A. And my standard form is f of x equals A times x minus h squared plus k, or y equals A x minus h squared plus k. So your answer is going to have a value where A is, a value where H is, and a value where K is. To get there, we're going to plug in the HK, the XY. The unknown will be your A. We'll solve for that A, and then we'll plug those 3 pieces of information back in. All right, so example 8 says find the equation of the parabola in standard form, then graph the parabola and identify the max min. So again, if you're the type of person that has to write things, like that's me, I have to write it over and over again. A x minus h squared plus k. Write it as many times as you need to until you remember that. Now be very careful and make sure you plug the right ones in where they're supposed to go. This is where people make silly mistakes. My vertex is my HK and my point is my XY. So when I plug back in as the answer, that 512 gets plugged in, not the 715. So my Y is 15, my A is my unknown, my X is 7, my H is 5, and my K is 12. The other thing people forget to do is square this. Like those are 2 silly mistakes people make on this test all the time. Don't do it. So I get 15 equals A times 2 squared plus 12, and 15 equals A times 4 plus 12. This is the other interesting thing people do is add the 4 and the 12. That 4 is part of the A. You cannot break up the 4A. You have to subtract the 12. So 3 equals A times 4, and then divide by 4. So A equals 3/4. Now I take and plug back in y equals, the a is 3/4, the x stays as x, my h is 5, so minus 5 squared plus the k, which is 12. You can also write f of x. Like, I'll take either of those answers. I won't mark either of those wrong. If it was a multiple choice, it would probably say f of x. But just know that either of those are fine. Now, what can you tell me about this parabola? What do we know? It opens upward. So does it have a max or a min? It has a minimum. How would I find the minimum? The vertex. Which part of the vertex? The y. So what's the y coordinate of my vertex? 12. Because my vertex would be 5, 12, right? This is shifted to the right 5, down 12, and it would be wide. So if you actually plotted these points, if I plotted 5, 12, and 17, 7, 15, 1, 2, 3, 4, 5, 1, 2, 3, 4, like my vertex would be up here. I went down 12. I should have gone up 12. This is a minimum of positive 12. That should have been up to 12. And then your graphs would match. So if you thought, like if you ever wanted to estimate, you wanted to check your work, that's an easy way to do it. Kind of give yourself an estimate. All right, last one, and this is your word problem. So word problems with parabolas have usually something to do with a ball being kicked or ball being thrown. There's divers jumping off a platform. There's rocket ships going up and coming down. They're making a parabola shape, okay? Typically, they go up and come back down because that's what objects do, which means you'll have a parabola that has a negative a. Then it could ask you about a series of things. How high does it get? Where does it hit the ground? When does it hit the ground? When does it hit its max? Where is it when it starts? So all those different things are parts of what we just talked about. Where it starts, where this kicker, where it leaves his foot, is going to be your y-intercept because that's where it starts. The max up here, the max height is the k coordinate of your vertex, but how long it takes him to get to that is the ax coordinate or h coordinate of your vertex. When does it hit the ground again? Now you're looking at, or if it says when does it hit the ground again? Now you're looking at the x coordinate of your 0. So all those things are parts of the function that we've already talked about. You just got to figure out what they mean when they say things. So I'm going to type this in. Remember your fraction shortcut is above your y equals because that's obviously helpful here. All right, so I'm going to clear this out. Mine is above the y equals. Some of you have it on the x, on the variable button, but I have to go second y equals and then hit n over d. Okay, so again, my shortcut is alpha here. Some of you are at the variable button. Then I'm going to do negative 16 over 20/25. And that negative could be out front on the 16, or it could be in the top like I have it. Doesn't matter. Just make sure it's the leading negative and not the minus. And then x squared plus my fraction again, or you can put parentheses, it doesn't matter. 9/5 x plus 3/2. So if I didn't know anything about that function, like if you didn't understand the parent function or the x squared, then this looks like a line, right? But this is a parabola, so clearly it's not a line. It's going to go up and come back down again. If you wanted to see the big picture, I could hit zoom and I could zoom out, right? Or I could figure out where the max is. And you could even find out the vertex here without using your calculator. The number's terrible, but you could do it. It's negative b over 2a, then plug that back in. But if I just wanted to zoom out because I don't know how high my window needs to go, then I hit zoom, I go to zoom out, and I hit enter. And then it graphs it like a snail. Why this one's so slow? Because I have to hit it again. You'll know your calculator is working because in the upper right-hand corner, there's a little guy that spins. So if I go zoom and I zoom out again and I hit enter, you'll see there's like a little thing that spins in the right corner. So it's like telling you to be patient because it's working. Okay, so I needed to see it go up. And if it asked about when does it hit the ground again, I needed to come back down. I still haven't seen it come back down, but I have hit the max, right? So at least I can get that part answered. B says, how high is the football when it's punted? So where is the punter? By way of the graph. Where's he standing? He's the y-axis. So whether somebody's throwing something from a balcony or they're throwing something from the ground or they're jumping off a diving board, whatever it is, they are the y-axis. So if you want to know how high that ball is off the ground when it leaves his foot, we're talking when x is 0, which means your y-intercept. So if I go second, trace, and I go to value, and I hit 0, that should match the C value here because that would be the y-intercept. And it does. 3/2 or 1.5. So 1.5, and we're in feet, or 1.5 feet, okay? Something like that. What's the maximum height of the football? So now I'm doing second, trace, I'm going to max. I'm already left of it, but I'm going to get a little bit closer. Left of my max. I have to see my y go up and come back down again. I'm right of my max. I hit enter again, and it's going to bring me to my max point. The x value is 113.90628. The y value is 1.401563. Which of those represents the maximum height of the football? The y. So 104 point, I don't know if it says to round. We're going to round to 1 decimal place. 0 feet. Now, if it had asked, how long after it's punted does it hit the max? Now you're looking at the x value, right? Now I would say 113.9, does it say seconds? It doesn't even give it, okay? That's how long it would take to get there. And then the last question says, how far from the football, from the punter does the football strike the ground? It's not in this view, but it's going to happen like all the way over here. It's going to hit the ground again. So if I do second, trace, and I go to 0, and I am left of it, I could arrow further over. I'm left of it. Now I lose sight of it, but if I hit here, and then I go to the right, it's going to cut me off. It doesn't let me go past there. So I have two options, zoom out again or just adjust your window. If I adjust my window, now I want my X max to be further. So if I just did like 250 here, 580 is kind of big, but 250 to see if I can catch the whole thing. It crosses through my x-axis again. So I can hit second, trace, 0. I'm left of it. I'm right of it. And guess, and it's going to bring you to the 0, which is 228.6 feet. So you've got to be comfortable enough with your calculator to be able to manipulate your window, your zoom, all those things, and understand what it's asking you. Maximum feet is obviously, or maximum height is going to be the k coordinate of your vertex. Where it hits the ground are going to be your zeros. Where it leaves or where it starts is going to be the y-intercept. So those kind of things always happen. You just got to understand what it's asking for. Questions on anything we talked about today? All right, in the homework, there's also like an area question that you have to come up with a quadratic to answer. These are great standardized test questions. So you definitely need to try all of them, okay? And remember that at the end where it says like 9, 10, 11, it says put it into standard form, then answer the questions. You have to complete the square. All that stuff, I'm looking for the work on those things.